Okay, first day back from break, and we are doing a little bit of review for a cumulative test. The cumulative test will cover two major topics. This kind, what was that again? It's got an X in the exponent. It's called a exponential. Very good. And that exponential has a starting value of what? 5. The number right there after the equals, that's the start value. Remember that? Trying to bring you back a few little kernels from the past. All right? If you're going to talk back there, I'm going to move you. All right. So what's this thing called? The what? Growth rate. Very good. In this case, 4% growth, true or false? False. What is it? 40% growth, okay? And if you had 5 things and they were growing at 40%, are there things that grow at 40%? Yeah, I mean, there's for instance, rabbits will multiply like crazy because they're the happy meal of the great outdoors. Everything likes to eat rabbits. So they have to make lots of little rabbits because they don't have any defenses. And these little rabbits need to multiply like crazy because they're just going to, tons of them are going to get eaten. And if you want any rabbits to be left over, you have to have lots of rabbits. All right. Where would you put the end value then? The X or the Y? The Y. What is the X then? The time. So if this is to represent a set of 5 rabbits that are going to breed and multiply at 40% for, let's say, 3 years, okay, then you could figure out the Y value. Wouldn't be too tough if you had a calculator. Does that ring a bell? Do you remember this? Then see if you could set up an equation like it for me telling you a brief story. Ready? Put the numbers in the right spot. This would be a typical test question. Let's say that there is a small town that has been based on mining. Okay, this mining town. And their population is in decay, as in they lose people every year. There's a little less people, okay? Let's say that they have 5,000 people left in the town right now, but they're going to lose them at 4% a year. There's 5,000 people in town now. They're losing population at a rate of 4% a year. The question would be, how long until they're down to 3,000 people? Write the equation for that. I'll say it again. There's 5,000 people now. They're losing it at the rate of 4%. How long till there's only 3,000 people? Now, this problem I'm choosing because it actually tests you on both exponentials and on logs, because at the end, you'll need a log to solve it. All right. If you have a calculator, grab it now. Okay, and I get how could you solve this? Like, what's the other thing? But I did say the ending number, which was what? How many of you guys set it up right? Raise your hand if you did. Awesome. Okay, now notice that's a minus in there. That's a minus in there because this is not a growth rate, it's a what? Decay rate. That's not showing a decay rate. Okay, next thing, if you're going to solve it, you're trying to get the X alone. First thing is you look for anything like, let's say there was a plus 7. You do adds and subtracts first. There isn't anything to add or subtract, so what's next? Multiplies and divides. Is there any multiply and divide we could do? Yes, we could divide by what? 5,000. That just cancels, which is awesome. And then not everything cancels here, but I can cancel it to 3/5. Would you agree that we have 3/5 equals 1 minus 0.04, also known as 0.96 to the X? Are you with me so far? Now that's all you would have had to do on an exponentials test. Okay. But now let's go to the logs test. They could have given you this and said, solve it using logs. So if we combine the two units, you can actually do more powerful stuff like this. We started with a real world situation, and now we can solve it with a log. Log base, well, I think you may not be ready for this, so I'm going to go back to it in a second. Let's say I had this, 5 equals 8 to the x. Can you do that? Yes, by writing it as a log. I'll remind you. You go like this. Log base. Well, which one of these is acting as the base? The 8 or the 5? The 8. Log base 8. Do you remember that you do not do it in order? You have to jump back and forth to the two sides. So log base 8 of what? 5 is equal to, it goes like this. Comes full circle. Remember that? The log base 8 of 5 equals x. And then if I had to put that in the calculator, it's got a base 8. And your calculator does base 10. So how are you supposed to do that? You have to change it with what's called a change of base. Do you remember me drawing a line like this and saying it was log 5 divided by log 8? That's how you'd put it in your calculator. Try that again. We did that on the very first day of logs, which is a long time ago. So I get that you might have forgotten. But figure out log 5 and remember to get the answer to log 5. If you type this in wrong, it'll do the wrong order of operations. You've got to put that end parenthesis around the 5. Log 5 divided by log 8, and we'll have our x. Just make sure you're typing in right. What did you get? 0.77. Raise your hand if yours would have rounded to 0.77. Awesome. If yours isn't doing that, then you're typing yours wrong, and you should try it typing it a different way. Again, you need this to be completed, so you need the end parenthesis on the log 5 parenthesis. That'll get it done. And then you divide by log 8. Now, why did I say I changed the base? Because this one had base 8. This one doesn't have a base. So therefore, what base is it? Base 10. Remember that? If I just say log 6, I can do that because it's sort of like, well, you didn't tell us the base, but it's just the most common one. So that's called common log, and it has a base of 10. All right, how about this? ln 7. That's got a base you can't see. What base is it? Log E. E, very good. So that's log base E of 7. A few formulas just to remind you, if they have things set up like this, they're begging for you to change that to a 5 so that the bases will be the same. So 25 is really like 5 to the, do you get how it'd be better if it was like this? Because when it's like that, the answer is just 2. Just to clarify why it's 2, I can set it equal to x and then do a rewrite. 5 to the x equals 5 to the second, x equals 2. Okay. If you understood that, what's the answer to that? Don't say it out loud. Think about it. Think about rewriting so that the bases will be the same. Those two are equal. The answer is that. Who remembers the dumb saying for this? You won the argument, so? Nothing. 0. The answer is 0. And if you had to work it out to prove it to your friend, because they think, no, I think the answer is 5. Here's how you'd work it out. You'd say equals x, and you'd say 5 to the x. Oops, that's not the right power. To the x equals 1. And then you ask your friend, what does x have to be? X has to be 0. It's the only way that would work. So x must be 0. Therefore, this equals 0. How about this one? I know the answer. Do you know the answer? All right. Say it if you know it. 5 is correct. But wait, you say, there's not two bases that are the same, but there actually is. Because if there isn't any base written, then it must be a base 10, and it's all about that base. Because that'll be the same as that, which makes the answer 5. All right, one more pattern that you saw a lot was like this. 9 to the log base 9 of 7. I'm trying to make it really obvious. They both have the bases showing. The bases are the same. The base are the same. What's the answer? 7. So here's where that gets a little more obscure. If I say 10 log 3, it's like you don't see the two bases that are equal, but you think it through. And what I said is, anytime they don't write the base, it'll be all about that base. Because, I know Megan Trainor said it first, but those being the same means that the answer has to be what? 3. All right. And then this one is even more obscure because it involves this E thing, which seems like it's a variable, but it's really not. What does E actually stand for? It's about 2.7. And that's just a number. And LNs have a base too. I've said always rewrite your LNs as log base E. Base are the same. Answer 7. All right, so there's your quick reminder on logs. Here's another little tidbit. Do you remember doing these? Let's say it was that. Log base 2 of x plus log base 2 of 25 is equal to 1. Not nice, not easy, but you'll never solve this until you put the logs together into one log. Do you remember how to do that? Condense this down to just one log. And then you can use the most powerful strategy of them all, which is the rewrite. It's funny that the way you can solve logs the best is by making it not be a log anymore. If it's not going to be a log anymore, it must be a, what's the other kind? Nope, exponential. Okay, so you should have said log base 2 of 25x is equal to 1. And then you can do a rewrite. 2 to the first is equal to 25x, which is really pretty easy, isn't it? Then you just divide both sides by 25, so it's 2/25. All right. You don't have to do anything tonight, but if you want to get started on your homework, what's going to happen is there's 2 review worksheets. I'm going to assign all the even problems from both of them, and then maybe some of the odd ones also. So, long story short, do as much as you want to get ahead, because if you have no other homework tonight, be nice to yourself, get it done. Take the first review worksheet that's in the folder and start on the evens of it. Okay? All right, that's all I got for you for today.